All right, hello folks watching this. This is 9-3. This is the start of 9-3. We're going to do just example 1, but I have already said that this is the nicest section of the chapter because take a look at how beautiful this equation is. We haven't had an equation that nice in like the whole chapter, right? Look at all that. That is so nice, okay? Now, this is an extension of 9-2. We're still doing mean, okay? Now, mean, what variable do we use for mean? Mu. We're still doing mu's. But the deal here is that, circle this, we have something called matched pairs, okay? Matched pairs. So yesterday we had 2 samples, and we had like N1 and N2. Okay, listen. Shh. We had N1 and N2, and N1 was like 12, and N2 was like 15, meaning we had one data set with 12 and one data set with 15. We do not have that today. Today, we have the same number of data in each set. So like if we're testing males and females or actresses and actors, we have the same number of each, okay? And that makes it nicer because we can match them up, okay? They do this a lot of times when they do studies on like pharmaceutical things or like drugs and stuff. They will take 2 people in a placebo group and a control group, and they will match them together, okay? So if I'm testing like a diet supplement, right? Like I want to see if my diet pill works. I'm going to take 2 people that are almost the same weight and body dimensions and everything, match them up. I'm going to put one of them in the drug group and one of them in a placebo group, right? Okay? And I match them up and I see, okay, does my drug, my weight loss supplement affect the person that's getting it and the other person stays the same weight, right? That's what I'm looking for. So I match them up, and so we have the same number in each data set. So the way that this works with matched pairs is that N1 will always be equal to N2. We have them matched up, right? We don't have more in one data set than the other. Shh. Okay?
Shut up.
All right, now here's the deal. When we go to do our hypothesis testing, let me write this over here. H naught is equal to, or H naught is, I'll put colon, okay? H naught, we always say that mu1 is equal to mu2, okay? Now, instead of saying that, shh, be quiet. Instead of saying mu1 equals mu2, when we do matched pairs, we're going to say the same thing but a different way. We're going to say that mu d is equal to 0, okay? Now, let me talk to you about what that means. If mu1 equals mu2, the average like for each data set is equal. We are going to now not say it that way. We're going to say that the mu d equals 0, which is the differences between the 2. So if the 2 are equal, then the difference is none, right? Like there is no difference. So mu d equals 0, that's going to mean that the differences are not anything at all, right? Okay? And then for our H1, it's going to be that mu d is not equal to 0, mu d is less than 0, or mu d is greater than 0, okay? Now, if we say that, then that means that mu1 is not equal to mu2. That's like what we would have said before. If mu d is less than 0, then that means that mu1 is less than mu2, okay? If it's greater than, then that means mu1 is greater than mu2. So rather than saying it this way, go back. Where did I go? There we go, okay? 2. So rather than saying it this way, we're going to say it this way instead. We're going to talk about mu d, the differences between the 2. Got it? Okay? All right. If you guys don't stop, we're going to do example 2. I promise you. Be quiet. Okay? I totally promise you. All right. So, hypothesis, mu d equals 0. We're going to write it like that instead. Let's go to this example, and I'll talk to you about the differences. Our equation is super, super, super easy. Okay? Actually, let's talk about the stuff here. D bar, which kind of sounds weird. D bar, okay? This is the mean of the differences. E-R-E-N-C-E-S. Write that down. The mean of the differences is what D bar is, okay? Now, mu d, they put this in here. But if our hypothesis is that mu d equals 0, then we can just cross him off. That's what 0 will be. You remember how we do that in the equation a lot of times? Okay? If we are assuming for the hypothesis that mu d equals 0, we can just put 0 in that spot.
Why did they even put it in there?
Because in later chapters it won't be 0. Okay?
Are we doing those later chapters?
No. Well, we'll see. We'll see if we get that far. Okay, what's SD?
Standard deviation.
Standard deviation. for the differences.
That's
Okay.
SPD.
And then n is the number in
Sample.
each sample. Okay? The number in each sample. Okay, here we go. That's my equation. We're still using the T or the Z chart for the critical number. We'll get to that. All right, so we're talking about actresses and actors. All right, so we've got this data going on here. Because they are matched, okay? This is the data set that it gives to me. They give me the ages for our best actors and best actresses, okay? We are going to subtract the two. When there are matched pairs, we're going to subtract the two. So first thing we do is we take the top one minus the bottom one. So 28 minus 62 is negative 34. That's how they get this number, yeah? You need to watch. Okay? Next, they do 28 minus 37, that's negative 9, right? 31 minus 36, they keep going, right? They do the top minus the bottom one. Okay, they do mu1 minus mu2. These are our ones, our actresses are our ones, our actors are our twos. So you do 1 minus 2, and then you get the differences. And this is the data set that I get, okay? So because they're matched pairs, I can get from having two sets of data down to just one set of data with the differences, right? Okay? And then in my formula, what I need is I need D bar, I need SD, and I need N for my formula, okay? D bar is the average of the differences. So this little data set, these 5 numbers that I have now, I'm going to take the average of them, right? Okay, what did you get?
Negative 10.2.
Negative 10.2, write that down, okay?
And 14.7.
So Mal took the
5.
averages of just this line, right? Just that line, okay? The standard deviation was what?
14.7.
14.7, and the N, how many N's do I
5.
have? 5. I have 5 numbers, right? Okay, now, a lot of people think N is 10 because I have 10, like, total. N is just how many pairs you have. So, N is 5. Got it? All right, so our hypothesis is that mu D equals 0. Okay? All right. What is the actual difference between the two on average? Negative 10.2. Let's talk about what that means, okay? We are taking actresses and minus actors, okay? What do you notice about all the actresses' ages versus all the actors' ages in particular, mostly?
Actresses are younger.
Actresses are younger, okay? This is the way that it works. Women, we age, right? We get wrinkles faster, like men stay somewhat good looking, like later on in life, right? Like that's just the way that it works. Like life sucks, okay, as a woman, okay? We get like wrinkles, we get fat, we get, all of those things, okay? So if we are going to be actresses in movies, we're going to be more successful when we're younger, right? Versus like the Patrick Dempseys and all of those people who can like work into their 70s probably. He'll still be in movies, I'm sure. Tom Cruise, all of those old actors, okay, they can get away with that because they're still good looking, okay? Women are not going to be good looking later on in age. So what we have going on here is we have a difference in age, right, for actors versus actresses, right? So we're trying to see if there is a legit difference. It looks to me like there is a legit difference, like negative 10. That means there's an average of 10-year gap between males and females on average for best actors and best actresses, right? We're going to compare that to 0. Do you think 10 years is comparable to 0 years? I think that's a pretty big difference, right? We're going to see what the difference is, all right? Let's go back up in here and see if we're trying to see the differences have a mean less than 0. So that's what we're testing. So our alternative hypothesis is mu D is less than 0. Now let's run the test. We have a left-tailed test. Okay. And what's our fish value? Find it in the top. 0.05. So we put all 5% in there. We have like an imaginary 5% here. And that means 90% in the middle. All right. So we're looking at 90%. And degrees of freedom would be? 4 degrees of freedom. Okay. 90% at 4 degrees of freedom. It's going to be like all the way at the top of the table. What are my two numbers?
2.132.
What?
2.132.
2.132. So I've got a negative 2.132 and a positive 2.132. Okay, got it? That's my T value. 2.132. Got it?
And it's negative 1.
All right, we're not going to do the p-value method. We're only going to do critical value method for this one. Okay? And let's see, our formula right here. We're going to go to this. Okay, I'll write it down below here. T for our test value. Okay, this goes under the test statistic value. And formula, T equals, we got D bar
10.2
minus
negative.
mu D all over SD over the square root of N, right? It's kind of a similar formula to what we had before. All right, D bar was negative 10.2, right?
Minus 0.
Minus 0, that's always going to be the value of 0.
14.7.
14.7 divided by the square root of 5. And you get a number.
Negative 1.55.
Negative 1.55.
Which
Oh. Oh, I don't agree with that. I would not have agreed with those results. Okay, anyway, negative 1.55. Got it? That's our test value. He lives
in the middle.
right here. So, which one are you going to go with?
Circle.
Circle the top. Which means what?
FTR.
Failed to reject, claim false. Okay. FTR, because our claim went with, no, claim was false. Okay, FTR, H naught, claim false. So what does that mean?
They're the same age.
Yeah, so basically they're saying males and females are same age. I don't agree with that. I think that according to that table, it looks to me like women are younger, right? That's what I would have assumed. But they're saying they're not far enough in age apart to say that they are
that's
different,
a pretty big,
right?
10 years.
10 years on
That's a
average. An
big gap.
average of 10 years is a pretty big gap. Like, that's huge, okay? Do you see how that works? Okay?
Yep.
All right, so the deal here is number 1. If you're looking through number 1, all you have to do is find D bar and find SD. So you're going to subtract the differences. How do you know which way you're subtracting?
The one's on top. And
The
two's
top
on
one minus the bottom one. Okay, you're just going top to bottom, subtracting them. Then you're finding the average and the standard deviation of those. Okay, you might have to put them on a Google sheet if you want to. Okay, got it? And then make sure you answer the question. Okay, this number 2 and number 3 is where you're actually doing the test. Okay, part B, we're not going to do the confidence interval method. So if you need to use that room to work, we're not doing confidence interval method until we get to the back side. Okay. So, 1, 2, 3. 1, you're just doing the calculations. 2 and 3, you're doing all of the testing. Okay? But the formula makes it a lot nicer because you only have one number to deal with rather than like p hat 1 and p hat 2 or mu 1 and mu 2 or x bar 1 and x bar 2, right? You only have one set of data, the differences. Okay? Got it? All right, if you want to work together to get your standard deviations and your averages, so be it. Go for it. I don't care. Okay? There you go. Questions before I stop the video? All right.